right, this is our second lesson of 13.6. We're still working with probability. So this one says the students in an art class were surveyed about their favorite color. 32% preferred blue, 29% preferred red, 23% preferred yellow. Out of 450 students in the entire school, how many would you expect to say they prefer red? So we're going to set this up as a proportion. So we're trying to find out of 450, so that's going to be x over 450, how many preferred red? So we know that 29% preferred red, so we can write this as 29 over 100, because we know a percent is over 100. From here, we just cross multiply. So 100 times x is 100x. 29 times 450 is 13,050. I'm going to then divide both sides by 100, and I get x equals 130.5. So I would round that up to say about 131 students prefer red. Number 2 says if you spin a spinner with the numbers 1, 2, and 3 on it and toss a coin, find the probability of getting a number 1 and a head. So for this, we're going to create a sample space. So for my coin, I have 2 options. I can get a heads or a tails. For my spinner, I have 3 options. I can get a 1, a 2, or a 3. So I'm going to create a sample space here and write out all my options. So I could get a 1 and a heads, a 1 and a tails, 2 and a heads, 2 and a tails, 3 and a heads, 3 and a tails. So it says find the probability of getting a number 1 and heads. So there's 1 option out of 6. So the probability of that is 1/6. The only thing that's different today is to find the probability of landing in a specific region. We use area of a specific region over area of the target. So it's still going to be want over total. That's still the ratio that we are going to use. This one says if you have a square board like the one below, what is the probability of throwing a beanbag through the hole in the middle? So again, we're using want over total. We want the inside circle, and the total is going to be the entire square. So I'm going to write it like this. We have the area of the circle over area of the square. Area of a circle is pi r squared. Pi r squared, pi is 3.14. Our radius is 5, so 5 squared. 5 squared is 25, so I'm going to take 3.14 times 25, and I'm left with 78.5. So that's the area of my circle. That goes on top. Then the area of the square, if one side is 20, that means all sides are 20 inches. So I just take 20 times 20, and I'm left with 400. So we have 78.5 over 400. What I'm going to do is I'm going to change that into a percent. So I'm going to take 78.5 divided by 400, and I'm left with 0.19625, which rounded up would be about 20%. So there's a 20% chance of landing in the circle. The next one says the spinner is divided into 8 equal sections. Laura spins the spinner 120 times. It lands on purple 30 times. How many more times does Laura need to spin the spinner and have it land on purple for the relative frequency to equal the theoretical probability? Our goal in this problem is to get the experimental probability to equal the theoretical probability. So our experimental probability, she got it 30 out of 120 times. That's, I'm going to put that E for experimental. Theoretical, if you look at our spinner, there's 8 total. And then, how many are purple? 3. So 3/8 is our experimental probability. Right now, 30 over 120, if I simplify that, that leaves me with 1/4, which is not 3/8. So how we're going to do this is we are going to set up a proportion, and I'm going to start first with my experimental probability. So 30 over 120. We need to figure out how many more times she needs to spin the spinner and have it land on purple to equal the theoretical, which is 3/8. So I'm going to take 120, because that's the total amount of spins, plus x. How many more spins does she need? We're going to pretend that all of those spins are purple. So we're adding that to our 30 purples. So we have 30 plus x over 120 plus x. I'm going to put these in parentheses, because what's going to happen now is we're just going to cross multiply. So I'm going to take 8 times 30 plus x and set that equal to 3 times 120 plus x. Then all we need to do is distribute. So I'm going to distribute the 8 here. So I get 240 plus 8x equals 360 plus 3x. We're not done because we need to solve for x. I need to get all my x's on the same side and all of my constants on the same side. So I'm going to start first with 240. Take that away from both sides. So I'm left with 8x equals 120 plus 3x. Then I'm going to take away 3x from both sides. And I'm left with 5x equals 120. Now I'm going to divide both sides by 5. And I'm left with x equals 120 divided by 5 is 24. So 24 spins. So I look at my answers, and my answer would be B, 24 more spins, and all landing on purple to equal the theoretical probability of 3/8. This one is the same idea. So the spinner is divided into 3 equal sections. Tom spins the spinner 28 times. It lands on the number 1 4 times. So there's our experimental probability. 4 out of 28. How many more times does he need to spin the spinner and have it land on the number 1 for the relative frequency to equal the theoretical? So my theoretical, there's 3 total, and there's only one number 1. So my theoretical is 1/3. Well, 4 over 28 is not equal to 1/3. So we're going to do the same exact thing. I'm going to take 4 over 28, and I'm going to pretend we're spinning it however many more times, and all of those times it's going to land on the number 1. So I add x to each of those, and that equals 1/3. I'm going to put these in parentheses and cross multiply. So we have 3 times 4 plus x equals 1 times 28 plus x. And then I just distribute and solve. 3 times 4 is 12 plus 3x equals 28 plus x. I then need to solve for x. So first, I'm going to subtract 12 from both sides. I'm left with 3x equals 16 plus x. Take away x from both sides. Left with 2x equals 16. Divide both sides by 2. And I'm left with x equals 8. So 8 more spins, letter C, for it to equal the theoretical probability. This one says Leon uses squares to make a board. He randomly throws a stone onto the board. What is the probability the stone lands on a space marked 3? Well, we're going to use want over total, but I need to make sure that all of these are equal. So all I'm going to do is I'm going to split these into fourths, and I know these are all 2s. I'm going to split this into fourths, and I know these are all 3s. So now all of these are equal, so now I can plug in what I know and solve. So my total number of squares, if I count all these up, I get 16. Then I count how many 3s there are. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 16, which is the same as 1/2. So D is the correct answer. This is some review. So it says the spinner has 12 equal size sections with the numbers 1, 2, 3, 4, 5, 5, 5, 6, 6, 7, 8, 8. Give all answers as percents. So the probability of odd number, the probability of a 5, probability of not an 8, and probability of less than 5. Again, for all of these, I'm going to use want over total. First thing I'm going to do is figure out my total, and it says there's 12 sections. So that's my total. So for all of these, it's going to be out of 12. And the first one is an odd number, so I figure out how many are odd. 1, 2, 3, 4, 5, 6. 6 out of 12, which is 1/2. And it says give that as a percent, so that's 50%. 50% of the numbers are off. The probability of getting a 5. Well, there's 3 5s, 1, 2, 3, 3 out of 12, which is 1/4, which as a percent is 25%. The probability of not an 8, well, if there's 12 total and there's 2 8s, that means 10 of them are not an 8. 10 out of 12 is 5 out of 6. To figure out what that is as a percent, I take 5 divided by 6, and I get 0.83 repeating, which as a percent is 83.3 repeating percent. And then a number less than 5, since it's just less than, it does not include 5. So there's only 4 numbers that are less than 5. 4 out of 12, which is 1/3, which is 33.3 repeating percent. We're going to skip that one. This one says you plant 30 violet seeds and 9 of them sprout. Use experimental probability to predict how many violet seeds will sprout if you plant 20 seeds. So again, we're going to set up a proportion, want over total, want over total. So we plant 30 total, 9 of them sprout. We're going to figure out how many would sprout if we plant 20 total. I'm just going to cross multiply here. 9 times 20 is 180. 30 times x is 30x. Divide both sides by 30. And I'm left with x equals 6. Then we have to ask ourselves, does that make sense? If we planted 30 and 9 of them sprouted, would it make sense if we plant 20 more that 6 would sprout? Yes, it would. It's important to ask yourself if your answer makes sense. If you were to get an answer of 25, that would not make sense, right? You can't have 25 sprout if you only plant 20. Okay, your assignment for this is a worksheet. It can be found on Schoology. You need to do this worksheet, and then we're going to do a review, and then we're going to have a quiz on probability.